Today we start part C of Module 4, Introduction to Divide and Conquer and Insertion Sort. Part C.1, start with Insertion Sort. First, let us look at the general divide and conquer. We just talk about some general view of it. So then we use the insertion sort as our first example in this part. All right. Here, let us consider a special case of divide and conquer. Actually, if we recall a little bit in our Module 3, we have solved several problems. We already used the divide and conquer. We already use it. And actually, we use it many times. Here, in this part, we want to have more discussion on it. All right. So what kind of special case? Here. Decrease and conquer, from this name, decrease and conquer, this is the terminology used in our textbook. It is not a common way to call it, because in most of other books, algorithm books or textbooks, references books, most of other books, they do not call in this way. Here, mainly the author of our textbook try to, split. For example, the top is the divide and conquer, right? So then the author split it into several smaller subcategories. So this is one of the category, decrease and conquer. But in my view, so I feel we do not need to make that kind of split. It's not necessary. We just treat all such problems divide and conquer. So that should be good enough. All right. Here, let's look at it. Under a similar situation, all right, when we solve a general problem, we take this approach, exploiting the relationship between a problem to be solved, computing problem to be solved. Here I just use a problem and a solution to a subproblem. Really between a solution. Here I skip a solution to a problem and a solution to a subproblem. Exploiting the relationship. This is the key step. So you can see we only have just the one sentence, but this is really the key step. Because if you get this step, you almost get the problem solved. That's simple. If you can do this step, you almost get the problem solved. That's simple. All right? How to divide? There are several cases. Divide. The first one, decrease by a constant. Every time we reduce the problem size, decrease what? Decrease the problem size by a constant. Reduce by a constant. This pattern, this is one way people solve this kind of problem. Second, decrease by a constant factor. Division. So decrease by constant. So this is subtraction, right? You do subtraction. this way, you do division. Yeah. Decrease by a constant factor. Another possibility. Then the third one, variable size decrease. Yeah. Here it's hard to, use a special operation like subtraction, division. No, because variable size, we have a good example. In our module 3, we learned a good example for this third case. GCD problem. Okay? Yeah. GCD, greatest common divisor, GCD problem. This is a good example for this case number 3. Yeah. All right. So then, all these different cases, we treat. So I feel we just treat as the general divide and conquer. So we do not need to, using some new terminologies for each subcategory, give it a new name. Because if you do in that way, something that is not convenient when you discuss these methods with other people in the computing community, they do not know what we are talking about, right? What is the decrease and conquer? Because when those people, they learn algorithms, they didn't use these terminologies, right? But if you just use divide and conquer, everybody knows it. You do not need to explain. Divide and conquer. Everyone in the computing community should know it. So for that reason, I feel we just use the standard general divide and conquer method to cover all the variations, smaller variations inside this big category. All right, so let's go to the next topic, recursive or non-recursive implementation. Here we're talking about implementation because when you complete this step, typically you have a recurrence relation. This step will result in recurrence relation. Right? Recurrence relation. But the next question is how to implement this recurrence relation. There are two ways. The first way, recursive way. Second, non-recursive way. Non-recursive method, we can implement it. We can implement it. If you recall the Fibonacci numbers, how do we solve Fibonacci numbers problem? We have recursive method and the non-recursive, right? Now for loop, iteration, iterative. So you have that idea. But here I talk about a general case. Suppose that a relationship has been developed between a solution to the problem and that of the subproblem. So recurrence relation. All right. It results in a recursive method. First, we do not need to do anything special. We just apply this formula. We write a code to implement this, relation directly. We have a recursive method. That's the first way. But there is an option. We could consider it. There is an option. You do not have to do it, but sometimes, probably, you may like to think about using this non-recursive way. So why is that? The reason is simple. Changing from recursively to iteratively. Reason. use less storage space. Use less storage space. Why is that? Due to the stack implementation for recursion. The recursive method, how to implement in main memory stack. Look at our homework question number 1. In the video, I explained that, the background. How to manage the memory resource to implement recursion. I drew diagram there, explain the background. Here we use that knowledge. All right, So you can see, iterative way, we do not need a stack, right? Iterative way, we can avoid, we avoid using stack. We do not need to use stack. The stack can consume a lot of memory resource. So that's the reason we can use less storage space or memory resource. Here the storage space, that's the memory. Inside the memory, the temporary storage space. Temporary storage space inside memory. All right. The method to be used, so here I write this here. All right. Bottom-up approach. We start from smallest possible problem sizes, usually, with base cases. All right. Starting with a solution to the smallest instance of the problem. We know that is what we call the base case. All right. For any recurrence relation, we should have one or sometimes more than one base cases. Here we start from there. Next, iteratively solve a larger instance of the problem, incremental way. Using that recurrence relation, because for the smaller problem instances, we have the solutions. We already have the solutions. So we do not need to use the stack. The reason we use the stack, we don't have those solutions. So that's why we push those sub-problems into the stack for later computation. But this way, iterative way, we always use known solutions for smaller problem instances to find the solution to larger problem instance. All right, so that's the general discussion for divide and conquer. All right, the general discussion. Next, I like to go to the insertion sort. It is pretty simple, but the idea is very useful. Now, it is a very special sorting algorithm, but it is very useful. So let us study the details. Very simple, All right. First, we revisit our sorting problem. So we're familiar with this problem. All right. The strategy here, strategy divide and conquer, right? Obviously, divide and conquer. So we start with a simple case. After that, then we grow the data size gradually. How much? Gradually, right? The step size, how big you move to increase your problem size, that step size increase by 1. Every time we just increase our array size by 1. Yeah. The size we mean array size. Yeah. That's simple. Okay, yeah. All right. But when you have that kind of general idea, the next thing is you need to connect two adjacent cases. Two adjacent cases. Yeah. Yeah. So let's think about this. Suppose the problem size of n and the problem size of n minus 1. Yeah. How do you connect these two cases? That is the key for this solution. Yeah. All right. Working on the problem size. Let us do the work, do the analysis work. Here, let us just use our intuition. Yeah. Let us use a diagram to really get to the details of this method. Yeah. When we start a one element array. Yeah. So this is the representation of one element array. Yeah. The arrow bracket, a pair of arrow brackets represent an array. But in this array, we only have one element. Yeah. Now, next, we need to insert a new element into it. Add a new element into the current array. The current array is a one element array. All right. How to add it is simple, right? It is trivial. It is trivial. You just do one comparison. You can make these two elements sorted. One comparison. So that's the trivial step. All right. After that, we will have a new array. So this new array already sorted, right? Yeah. You can treat that one element array also sorted in increasing order. It is a special case. Array sorted in increasing case. Yeah. All right. Then we move to the next subproblem. This time we need to insert little a2 to the current already sorted array with two elements. All right. I believe you can do it, right? Yeah, you can do it easily, right? Here, I delayed that discussion. Yeah. So we just assume we can use some way to, after a certain number of comparisons, we add a new element a2 to the current array and get the whole array sorted. Yeah, we can do that easily. Yeah. Then we keep doing that. So you can see every time we increase the problem size by 1. Every time we add a new element into an already sorted array. All right? Yeah. All right. So that is what we are doing. The general description, what we are doing. Add a new element to the currently sorted array and make it sorted. So this is the, typical step for this method. Yeah. Then the general problem description, we have an sorted array, increasing order sorted array with k elements. But we need to insert a new element ak somewhere into the current array and get a whole array sorted. So that's the solution we want to use to solve this problem. We know there are many different solutions, but here we just use this particular solution. There are many solutions, but here At this point, we just use this solution. All right, observation. At the end, we want to make conclusion. The conclusion is we have this key observation. So this observation is the key to the solution. All right, so what's that? Insert an element in a sorted array at the right position. We need to find the right position, right? Yeah. We need to find the right position. After that, we need to insert new element at that right position and then get the whole array sorted. Yeah. Here you can see the main keyword, this insert keyword. Insert the keyword. Yeah. Yeah. So later you will see this insert keyword corresponds the sort name. We call insertion sort. So later we make our sort name under this keyword, insertion. Yeah. All right. Next, we need to study the insertion operation. Yeah. Because in our discussion, we skip that details for this part, C.1. Yeah. But in our C.2, we need to discuss the detail of this insertion operation. Yeah. All right, so let me stop right here, and next we will go to the insertion operation.